Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Haziq bin Wan Muhammad. My matric number CE190024. Okay, today I want to present a run through of atomic layer of semiconductor. So my group name is Afid Irfan bin Yahya, Zul Rizlan bin Muhallif. So introduction. First, in accordance with the progress of moral law, the semiconductor industry has progresses from microelectronic in the 1980s and nanoelectronic in the early 2000s to the current state, in which we are entering an atomic scale age, which is this shift is taking place as we move into the period. Chip manufacturers are facing an unprecedented obstacles in the form of developing new technologies for the sub-10 nanometer technology node. Okay, next, atomic layer etching is one of the most promising ways to get at the low process variability that is needed in the edge of the atom. This method uses a series of self-limiting reactions to get rid of small layer of material. The basic idea behind atomic layer etching is that the first step is to change something which creates a reactive layer. Okay. The next step is to remove only the chain layer, which is called the limitation step, which is ions make it possible to etching in a certain direction, which is needed to make structure that are deep and narrow. Lastly, why atomic layer epitaxy atomic layer etching is overcoming this problem and make progress toward widespread use. It is also building on the well-established technology and capabilities of its counterpart, atomic layer deposition, which is widely used in the semiconductor industry to deposit thin conformal film. Okay, next we go to problem statement. Okay, first, one reason is the high volume manufacturing need to be cost effective, and multi-step process like atomic layer etching can have low throughput because the reaction steps are slow or because it takes a long time to switch from one step to the next step. Okay. One of the first study on silicon atomic layer etching say that a single cycle took more than 3 hours. This show how long the process take. Most of the time, lab cycle time for silicon atomic layer etching have ranged from 1 minute to more than 5 minutes. Okay. Second, new approach that are great toward manufacturing are being made to make atomic layer etching faster and cheaper. Atomic layer etching with plasma head can be used with existing etching equipment. Atomic layer etching can be used as a final touch up after continuous etching, and more advanced control system can be made for faster gas modulation. Lastly, also some application may be able to with a slower cycle time. For example, as features get smaller, there are more chance for thin film removal. 10 nanometer where throughput are not based on process but on the time. It could take to more material into and out of the reactor. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Izlan bin Muhalif and my metric number is AE190031. So today I will present for my part, which is future. So for the first point, to improve comprehension of the procedure, the benefits of plasma-assisted processing are included in the mechanistic knowledge for the silicon ALE case study. Next, acceptable feature size variability is anticipated to be on the order of silicon atoms during the next 10 years, including contributions from surface flaws. Variability, which is including surface contributions, has a major influence on device performance, which raises current leakage and battery power loss, and in turn lowers yield owing to failing device and have a substantial impact on their electrical characteristics. And the significance of cutting-edge plasma approaches for regulating ion energy distributions arriving to the wafer and plasma species formation routes is then brought to light for a successful plasma-assisted ALE. So that's all for my part. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Afif bin Yahya. Now I will explain the discussion part of our project. So one of the topic in our review paper discuss about the atomic layer etching ALE criteria, which consists of two steps, which is the modification and the removal. So for the modification step, it forms a thin reactive surface with a well-defined thickness that is easily removed rather than unmodified material. And the removal step eliminates modified layer while keeping the fundamental substrate intact. So next, one of the topic that was discussed also involves the characterization test, which is 3 independent tests to characterize ALE, which is the first step is the synergy test, and the second is the saturation curve, and the third one is less frequently used, which involve the energy scan. This test help to specify what degree the ALE process approaches its ideal behavior. So this is the energy diagram. So the first region shows the incomplete etching, which for low removal energy. The second represent the ALE windows, which exists because the energy barrier to remove the modified layer. And the last region, which is the third region, represent over etching for high removal energy. So as the conclusion, we can summarize that atomic scale of semiconductors are very fascinating given the many theories and experiments done by previous scientists and researchers. Next, semiconductors have come a long way through since it began in 1974 with the invention of rectifiers. And nowadays its application range from simple circuits to complex biochemical systems. So we can summarize that semiconductors plays a very vital part in our daily lives. So that's all from our group. Thank you.